Hi everyone, welcome to our next video lesson. We're on section 3.2. We're solving systems of linear equations. I believe you have all done this before in the past, but when we're solving systems of equations, what we're doing is we're finding what x and y equal, or we're finding what the variables equal. Most often it's two variables. It can be more, but more often than not we're going to solve for two different variables. There's three ways to do this. We could solve by graphing, solve by substitution, and solve by elimination. We're going to go over all three of those in this video lesson. So the first one is graphing. Solve these systems by graphing. So the intersection point, we're going to graph both of these lines, and where they intersect is going to be our solution. So let's first graph this top one, y equals 2x plus 1. It has a y-intercept of 1 and a rise of 2 and a run of 1 for a slope. So we have a line that looks like this. Once again, you don't have to put in these other lines that these other points that I put in sometimes, but it kind of helps to make a straighter line if you aren't using a straight edge on some of your notes. Please make sure you always use a straight edge on your tests. So there's that line, and now we are going to graph this one. I think I could speak for all of us when I say that we feel most comfortable graphing out of slope-intercept form. So let's change it into slope-intercept form by subtracting an x. We would now get 2y equals a negative x plus 12. I hope everyone sees that I just moved this x over to here. So now I'm going to divide both sides by 2, and I have y equals a negative 1/2 x plus 6. A negative x divided by 2 is a negative 1/2 x, and 12 divided by 2 is 6. So now graphing this line, we have a y-intercept of 6 and a slope of, let's see here, 1, 2, 3, 4, 5, 6, and a slope of down 1 over 2. Down 1 over 2, down 1 over 2. So we have a line that now looks like this. So when we solve for a system of equations, the intersection point right there, that is going to be our solution. So what is our solution on this one? That intersection point is at right 2 up 5. So our solution is 2, 5. And this is how I want you to write your answers, 2, 5. These are very, very simple to check, and I would recommend that you check every single one of these on a test. All you need to do is put this in for x and put this in for y, and see if the left side equals the right side. So we'll do that on this first one. Y equals 2x plus 1. Well, I now know that y is 5, so now 5 equals 2 times x, 2 times 2, plus 1. So now I get 5 equals 4 plus 1 is 5. 5 equals 5, it checks. Do the exact same thing for this one. We're going to get x, which is 2, plus 2 times y, which is 5, equals 12. Well, 10 plus 2 is 12. 12 equals 12. That one checks. So these ones are all very, very simple to check, and I would recommend that you would do that on every single problem. Maybe not on an assignment, but certainly on a test. Be sure to check every single one of them. So that's how you solve systems of equations by graphing. Simply graph both of the lines and see where they intersect. That intersection is going to be the solution. It's going to satisfy the equations for both x and y. That's the first method. The second method is solved by substitution. So what I like to think of is that when you're in a game or something like that, when you're in a basketball game or a football game, when you're substituting, you're putting in a person that is hopefully equivalent to the one who is tired. Right? If someone is tired and you sub for them, hopefully you're not subbing in a worse player. Hopefully they're the exact same type of a player. If it's a quarterback, you're going to sub in an equivalent quarterback, hopefully. If it's a center in basketball, hopefully you're going to sub in another center in basketball. So what is happening here is here's x and here's x. They are equal. They're the same x, so they are equivalent to each other. So if this x right here equals a negative 2 plus 3y, then this x right here also equals a negative 2 plus 3y. So we can substitute this into there. So when you have a variable by itself, substitution is a very good method to solve a system of equations. We're now putting this into there. So it's 2 times x. And what does x equal? Well, it equals a negative 2 minus 3y. That's what x equals. So that goes in for this part right here. Now let's write out the rest of this. Minus 3y equals 5. Now instead of 2 variables, we just have 1 variable. When we have 1 variable, we can solve for it. So let's solve for y. Let's use the distributive property. A negative 4 minus 6y minus 3y equals 5. Combine like terms. Move this to the other side. So now we have a negative 9y equals a positive 9. So what does y equal? Divide both sides by a negative 9. Y equals a negative 1. So now this isn't your answer. This is actually just half of your answer. This is the y coordinate for that solution. Let's now find the x coordinate. So to find the x coordinate, you simply substitute whatever y value you got into either of your equations. It doesn't matter which one you substitute it in for. So if y equals a negative 1, we'll just put that into this one. What is x equaling when a negative 2 subtracts 3 times y? And we now know that y is a negative 1. Solving for x, x equals a negative 2 plus 3, because a negative 3 times a negative 1 is a positive 3. So what does x equal? X equals a positive 1. So that's the other half of your answer. So here's how I want you to answer your questions. I want it in an ordered pair because it is a solution on a graph. It's an ordered pair rather on a graph. The x coordinate is 1. The y coordinate is a negative 1. So that's going to be our answer for problem number 2. You guys try problem number 3 on your own. Pause the video. Why don't you try that one? On this one, to use substitution, you have to get a variable all by itself. So you have to solve for x or solve for y. I would recommend solving for x on this one. It's the easiest one because all you have to do is subtract 3y. X equals a negative 3y minus 6. Because all you have to do is subtract 3y, and now you have x all by itself. So if that's the case, I'm now dealing with this equation and this equation. So now, if x equals a negative 3y minus 6, then this x also equals a negative 3y minus 6, because those x's are equivalent. So 2 times x, which x is now a negative 3y minus 6, minus a y equals 9. Distributing a negative 6y minus 12 minus a y equals 9. Combine like terms, a negative 6y and a negative y make a negative 7y. Add 12, add 12. You would get 12 and 9, making 21. Divide both sides by a negative 7. Y equals a negative 3. So hopefully everyone got that. Y equals a negative 3. Let's now find our x coordinate. Once again, you could use either one of these two equations to find your x coordinate. It doesn't matter. They're both going to get you the right answer. So we'll just use the top one again. 2 times x, I want to find what x is, minus y, and we found y to be a negative 3. That equals 9. So all I did was I used this equation right here, and instead of y, I put in a negative 3. So now let's solve for x. 2x minus a minus 3 means plus 3 equals 9. 2x equals, subtract 3, 6, so x equals a positive 3. So our answer is going to be an ordered pair of 3 for our x coordinate and a negative 3 for our y coordinate. Hopefully that makes sense. There's problem number 3. So we've done graphing, we've done substitution, we're now going to talk about elimination. Elimination, the word is there, eliminate. We're going to eliminate a variable. And the way you do that is you do that by multiplying the whole equation by a number so that one of the variables is gone. Here's what I mean by that. Let's make these y's disappear. by having the same number except one be positive and one be negative. So the least common multiple of 3 and 2, the least common multiple is 6. So let's get both of these to be 6y. One a positive 6y, one a negative 6y. And then when we add them, they are eliminated. Thus the word elimination. So let's multiply this by 2. Because when we do that, we're going to distribute. So if I multiply one thing by 2, I have to multiply everything by 2. So now we're going to get 4x plus 6y equals 2 times 12, 24. So I successfully got my 6y right there. So now with this equation, I want to get this part to be a negative 6y. So if that's the case, let's multiply everything by 3. Now let's distribute all of this. 3 times 5 is 15x. 3 times a negative 2 is a negative 6y. And 3 times 11 is 33. So now as you can see, I have successfully gotten my y's to be the same number, one a positive 6, one a negative 6. So now I'm going to combine like terms by adding these two equations. So what is 4 plus 15? I'm adding 4 plus 15. I'm adding my x's to get 19x. I add my y's. 6y plus a negative 6y is 0y's. We don't even write it out. That's the whole purpose. We're eliminating the y's. So they are gone. 19x equals now 24 plus 33. When I add these two, I get the number 57. So now I get 19x equals 57. Divide both sides by 19 to get x all by itself, and voila, we have our x-coordinate. X equals the number 3. Now all we have to do is find the y-coordinate, and the y-coordinate is pretty simple to find because all you have to do is use either one of these equations, just like in substitution. Put in your x-coordinate and find what your y-coordinate is. So we'll use this one. 2 times x, and we found x to be the number 3. So 2 times 3 plus 3y equals 12. 2 times 3 is 6. 6 plus 3y equals 12. So 3y equals 6. Divide both sides by 3. Y equals 2. So there's your ordered pair. Your x-coordinate is 3. Your y-coordinate is 2. And that's how you solve by elimination. Why don't you guys try number 5 all on your own. Get the letter N and get the letter A. Okay, after you try this on your own, it doesn't matter which variable you eliminate. You could eliminate N or you could eliminate A. It doesn't matter to me. I'm going to eliminate N on this video, but if you eliminated A, that's a very good way of doing it as well. I'm going to multiply this by a negative 3. That way I'd get a negative 6n, and this is a positive 6n, so now I could just eliminate from there. So I'm not going to change this one at all. This one I'm going to multiply by a negative 3. So I have a negative 6n minus 15a equals a negative 42. So I'm going to add these two equations. 6n minus 6n is 0n. They're eliminated. That's what I wanted to happen. 7a minus 15a is a negative 8a. That equals 10 plus a negative 42 is a negative 32. Divide both sides by a negative 8. A equals 4. So there's one of my answers. A equals 4. My other answer, I could use either of these two equations to substitute A in. It doesn't matter which one you use. I will use the top one. 2 times n, which we don't know, plus 5 times a, which we do know, a is 4, equals 14. So 2n plus 20 equals 14. 2n equals a negative 6 when I subtract 20 from both sides. So n equals a negative 3. So our answer is a equals 4, n equals a negative 3. You wouldn't have to write this one in an ordered pair. If you were to do that, write it alphabetically. So a would come first in the alphabet, n would come second, 4, negative 3. If you ever have an xy variable, I want it in an ordered pair. But if you get two letters like n and a that don't seem to have a relationship, you wouldn't have to write it in an ordered pair. You could leave your answer like this. Alright, one last reminder that I have for you. When you are working out a problem and your variables disappear, so if x is all of a sudden gone, y is all of a sudden gone, and then you get two numbers that equal each other, a true statement, 5 equals 5, then your answer is all real numbers. So you could write all reals, or you could write this, all real numbers. Okay? If you get something like, so once again, you're working out the problem and the variables disappear, and then you get a false statement, like 2 equals 5, we know that is not true. 2 does not equal 5. So if you get a false statement, then there is no real solution. So your answer is no solution. Alright, we'll go over maybe some more problems when you come into class tomorrow, but hopefully this makes sense to you. If it does not, please ask me some questions, because I could definitely go over this in more detail if you'd like me to.